In the prior lesson, we talked about the need for keeping sessions separate from one another in order for data to be sent and received simultaneously. And one way that people came up with to help accomplish that is by using a unique number for each individual session or connection in order to keep them separate and to keep track of them. And these unique numbers are now known as port numbers. Ports are logical, not physical, unlike Ethernet ports, and they tell the operating system what piece of software should handle a package. By having source and destination port numbers assigned to each connection, systems and applications can keep track of where to send and receive data. Let's use an example. Let's say that we have a web server running multiple services. One of those services is a web server serving requests over HTTP, and because you are security-minded, you've enabled all requests to be encrypted, and so you're sending all HTTP requests to HTTPS. To be able to administer your server, you've also enabled SSH for remote access, and if you remember from a prior lesson, both HTTP and SSH use TCP. Now, each one of those services uses a port number. For example, HTTP uses by default port 80, HTTPS uses port 443, and SSH uses port 22. The packet gets to the server verifies the used port, and sees that the destination port is 80. And because of how it's been configured, the server knows that this packet will be handled by its web server, let's say Apache, but that it needs to forward the request to port 443 in order to use HTTPS instead of unencrypted HTTP. Now, as we said before, your computer also needs to keep track of outbound connections, and so it also needs to assign a local port number to connect to that server. We'll explain in a little bit more detail how this gets assigned in just a moment, but for now, let's say that the port number allocated is 1331. Now, even though our computer already has an outgoing connection, we could open up a different website, repeat the same steps, and have a second outgoing connection using a completely different port. Let's say 25559. Now we're still using the same physical layer connection, such as Ethernet cable or Wi-Fi, but we're able to establish multiple different connections with completely different services over the same physical medium. An analogy to ports would be apartments. All of the apartments in the same building have the same physical address, similar to an IP address, but to know exactly who needs to receive the packet or package, we need the apartment number, which represents the port number. And once you have that, you're now able to send and receive packages to or from the correct apartment. Now, we just talked about how your computer also needs local ports assigned to establish connections, but how exactly are those ports assigned? Well, the port numbers range from 0 to 65,535 for both TCP and UDP. And this means that you can have a TCP port 23 in use while also having a UDP port 23 in use at the same time, but you can't have two TCP 23 ports open at the same time for two separate applications, or the same for UDP. You can specify the port number by adding a semicolon to the end of the IP address or domain name, followed by the port number itself. For example, since cyber.com is running HTTPS, you're technically accessing cyber.com:443, even if you don't see that in the address bar of your browser. The browser, domain name configuration, and web server configurations all work together to make it easier for end users. But if there was a service running on Cyber's web server at a completely separate port that you were trying to access, you'd likely have to input the port number after the domain name or after the IP address associated with the domain name. Now, within that range of ports that we just talked about, we do also have different segments of ports. For example, ports 0 to 1023 are commonly known as well-known ports. These are assigned by an organization called the IANA. Port 22 for SSH and ports 80 and 443 for HTTP and HTTPS are examples of well-known ports. Now, you don't have to use those port numbers for those types of services, it's not a strict requirement, but more often than not, people will use the defaults for simplicity. Then, ports 1024 to 49151 are known as registered ports, and they're also assigned by IANA, and these ports are used by vendors for their own server applications. The rest of the ports range from 49152 to 65535 and are commonly used by clients. These are known as ephemeral ports or dynamic ports because they're meant to last a short time and they're constantly changing. For example, when clients connect to a website, one of these ports is assigned to the session, just like we saw earlier. But unlike the other ports, these change frequently. The client is constantly cycling through them, and once a session is terminated, the port is available again for another session that could be completely different from the previous one. Now, as you spend more time in the cybersecurity or IT industry as a whole, you'll probably hear more and more about ports. On the security side, especially for pen tests and bug bounty hunting, you'll often hear of the need to scan and enumerate ports as part of information gathering. And the reason for that is because finding out what port numbers are open can give you a lot more information about what software is running on a particular system, and it can potentially help you find open doors into that system. Ports can reveal all kinds of information that's useful to an attacker, which is why they're important to know and understand regardless of whether you're setting up your systems, defending them, or even attacking them. Now, with that said, we've now covered ports, so let's go ahead and move on to the next lesson.